All right, in this video we're going to talk about angles. So this first slide is going to cover the basics of angles if you can't remember what angles are, or it's been a while since you talked about angles. So an angle consists of two sides and a vertex. And the vertex is where the angle comes together, or it's kind of like the hinge of an angle. So in this diagram we've got a few angles here. The red angle right here, we've got three ways we can name this angle. We can call it angle AXB, angle BXA, or we can name it by the number inside of the angle, angle 1. Likewise, the blue angle can be called angle BXC, angle CXB, or we can name it by the number inside. The red and the blue angles combined is this larger angle, so there's actually three angles in this diagram, AXC, or CXA. So that's just a quick refresher on what an angle is and how we name them. We're going to focus more in this video on angle relationships, and I'm going to talk about 4 types of angle relationships in the next slides, and here is a quick overview of the angles I'm going to cover. I'm going to cover vertical angles, and these are angles that are created when you have two lines that intersect. So in this picture right here we have two lines that cross, and you'll see that there are 4 angles formed. And the angles that are across the vertex from each other, or across the intersection from each other, those are called vertical angles. So angle 1 and angle 2 are vertical, angle 3 and angle 4 are vertical. And what we notice about vertical angles is that they are always congruent, or they are equal. They'll always be the same size. And that's how we write that in geometry right here with this symbol. That symbol right there, the equal sign with the squiggly on it, that means congruent, or equal measure, or the same size. Another type of angles we're going to talk about in the next slides are adjacent angles, and they are angles that share a vertex. So you can see angle 5 and angle 6 share a vertex, and they share a side. This side right here in between them, they have in common. They are adjacent. Now, adjacent angles aren't necessarily congruent. They can be, but just because they're adjacent, it doesn't mean they're congruent. And then lastly, we're going to talk about 2 types of angle measure relationships, and those would be complementary angles and supplementary angles. And right here, we've got a pair of complementary angles, angle 7 and angle 8, and they add up to 90 degrees. And that's what complementary angles are. They are angles that add up to 90 degrees. And if you'll recall, that little red box in the corner of that angle means that that is 90 degrees. So the measure of angle 7 plus the measure of angle 8 is going to be 90 degrees. That's what that little M means right there, the measure of angle 7. And then supplementary angles. Angles that add up to 180 degrees are supplementary angles. So again, the measure of angle 9 plus the measure of angle 10 is going to be 180 degrees. So let's look at these a little bit more in depth, each type of angle. So vertical angles, again, are angles that are across the vertex of crossed lines. So here I have crossed lines, and that creates 4 angles. The 2 blue angles and the 2 red angles are vertical to each other. So looking at the red angles in this red box, angle 1 and angle 3 are called vertical angles, and we know that vertical angles are congruent. That means the same measure. They're going to be the same number of degrees. However many degrees angle 1 is, angle 3 is going to be the same. So we say the measure of angle 1 is congruent to the measure of angle 3. And then likewise with our blue angles, angle 2 and angle 4 are vertical angles to each other, and they are congruent. So the measure of angle 2 is congruent to the measure of angle 4. So whenever you have vertical angles, you know they are congruent. That's vertical angles. Next, we have adjacent angles, and I think of adjacent angles like neighbors. Okay, they share a vertex and a side. So in this diagram, there are many angles in here, but I'm only going to be concerned with angles 1, angle 2, and angle 3. So the red angle, the green angle, and the blue angle. So angle 1 and angle 2 are adjacent because they share a vertex, which is right here, and they share a side right here. This side right here is in between angle 1 and angle 2. They both share that side. So angle 1 and angle 2 are adjacent. Angle 2 and angle 3 are also adjacent because they also share this same vertex, and this side right here, they share a side. So they are adjacent. Angle 1 and angle 3, however, are not adjacent. They do share a vertex, but they do not share a side. So angle 1 and angle 3 are not adjacent. Let's take a look at some more examples here. Here I've got angle 1 and angle 2 in this first diagram. These are not adjacent angles. They do share a vertex. Angle 1 and angle 2 have the same vertex, but they do not share a side. So only one of the requirements is fulfilled, so they are not adjacent. In the next diagram, I've got angles 3 and angles 4. They share a side right here. Angle 3 and angle 4 both use that side, but they do not share a vertex. They each have a different vertex, so they are not adjacent. And then the last one, angles 5 and 6, they are adjacent because they share a vertex and a side. So both requirements need to be met for angles to be considered adjacent angles. They have to share a vertex and a side. Next, we have complementary angles. And again, these are angles that have a sum of 90 degrees. So the first example, I have angle 1 and angle 2. The measure of angle 1 is 30 degrees and the measure of angle 2 is 60 degrees. So when I add them together, I get 90 degrees. So I would say angle 1 and angle 2 are complementary angles. And then the next diagram, I see that they're angle 3 and angle 4 both combine to form this 90-degree angle. I know the larger angle here is 90 degrees. So angle 3 and angle 4 are complementary because they combine to form that 90-degree angle. So complementary angles have a sum of 90 degrees. Then there's supplementary angles, similar, but they add up to 180 degrees. So again, the measure of angle 1 is 55 degrees. The measure of angle 2 is 125 degrees. So when I find the sum of the two, I get 180 degrees. So they would be called supplementary angles. Angle 1 and angle 2 are supplementary. And then likewise over here, I see when I combine angle 3 and angle 4 together, here's angle 4, here's angle 3, I get a straight line. And a straight line is 180 degrees. So I know when I combine angle 3 and angle 4, I'm going to get a straight line. So these are supplementary angles because their sum will be 180 degrees. So those are the 4 types of angle relationships that we were going to talk about in this lesson. Next, I want to talk about some line relationships. And perpendicular lines are 2 lines that cross to form 90-degree angles. So we would say that line L is perpendicular to line M. And then we've got that notation right here, that upside down capital T means perpendicular. So line L is perpendicular to line M, so that we know that the 4 angles that are formed, all of these angles are going to be 90 degrees. So when you have perpendicular lines, you form 4 90-degree angles. So let's take a look at these angles here. Let's classify them and then find the missing values here. So this first example, we have 2 angles here and we're trying to figure out the value of x, this angle right here. Well, I know that when I combine these 2 angles, I'm going to get this straight line. So I know that they have a sum of 180 degrees. So that means they are supplementary. So I know that if I add 146 degrees plus x degrees, I should get 180 degrees. So therefore, x has to be 34 degrees. So this is a 34-degree angle right there. Next one, these 2 angles, I can see that this is a 90-degree angle. So these 2 angles combine to form a 90-degree angle. That tells me they are complementary angles. And I know that 62.9 degrees plus x degrees has to be 90 degrees. And that means x is 27.1 degrees. 27.1 degree angle. And then lastly here, when I combine these 2 angles, I'm going to get a straight line if I were to slide those together. So that tells me these are supplementary. And x plus 105 degrees is going to be 180 degrees. That means x is 75 degrees. So we can start solving problems since we know these facts about geometry and angle relationships. Next, we're going to talk about line relationships. So we have parallel lines. We talked about perpendicular lines, but parallel lines are lines that are in the same plane but never intersect. So they will never meet. And these red arrows our geometry notation for parallel lines. So whenever you see arrowheads on two lines, that tells you that those two lines are parallel to one another. So we would say that line S is parallel to line T, and then we use those vertical bars there to indicate parallel. That's the symbol for parallel. And then we have what's called a transversal. Line R is the transversal, and a transversal is a line that crosses two or more lines in a plane. So since this line crosses both of those lines, it's called a transversal. So what happens when we have parallel lines crossed by a transversal? We get all kinds of angles and angle relationships. So we're going to talk about in the next few slides these angles that are created and the special angle relationships that are formed. So we have two types of angles when we have parallel lines cut by a transversal. We have interior angles, and those are the angles that are inside of the parallel lines. So angles 3, 4, 5, and 6 are all considered interior angles. And then we have exterior angles, and those are angles that are outside of the parallel lines. And angles 1, 2, 7, and 8 are exterior angles. And then we'll have all kinds of relationships in here. We do have some vertical angles in here. We have adjacent angles in here. We have supplementary angles in here as well as these three types of angles: alternate interior angles, alternate exterior angles, and corresponding angles. And I'm going to talk about those in the next coming slides. Alternate interior angles are angles that are on opposite sides of the transversal and inside the parallel lines. So you can think of it like this. So I've got these two interior angles, angle 3 and angle 4. So angle 3 is the red angle and angle 4 is the blue angle. Now if you think about flipping these parallel lines and lining this back up again, you see that now the blue angle is on angle 6 and the red angle is on angle 5. So angle 3 and angle 5 are kind of like mirror image angles to each other. So they are congruent. Angle 3 and angle 5 are actually going to be the same size. They're the same angle. So alternate interior angles are going to be congruent. They're the same angle. They're kind of a reflection of each other. Same goes for angles 4 and angle 6. So these two angles are actually the same angle. And then angle 3 and angle 5 are actually the same angle. So alternate interior angles means they're on alternate sides of the transversal, and they're interior angles. And we know that they're going to be congruent. They're going to be the same size. Alternate exterior angles, kind of the same story, but they're on the outside of the parallel lines. So again, angle 1 is my red angle and angle 2 is my blue angle. So if I kind of take these parallel lines and flip them and then reline them up, you'll see that the blue angle is on angle 8 and the red angle is on angle 7. So I know that angle 1 and angle 7 are actually the same angle as well. So angle 1 and angle 7 are the same, and angle 2 and angle 8 are the same. Again, kind of a reflection of each other. So angle 1 is congruent to angle 7, and angle 2 is congruent to angle 8. So those are alternate exterior angles. So angles that are on the outside of the parallel lines, but on opposite sides of the transversal. So alternate exterior angles are also congruent. And then the third type, we have corresponding angles. Now, corresponding angles aren't really mirror images of each other. They're angles that are in the same position, but on different parallel lines. So you'll notice that angle 1, angle 2, angle 3, and angle 4 are all angles that are on line J. They all use line J as one of their sides, and none of them use side K. But if we were to take this and slide it down so that all these angles were on line K, you can see that, well, there's kind of some matching angles here. Angle 1 pairs up with angle 5, angle 2 pairs up with angle 6, angle 3 pairs up with angle 7, and angle 4 pairs up with angle 8. So those are also kind of matching angles. So angle 1 is congruent or the same as angle 5. Angle 2 is congruent or the same as angle 6. Angle 3 is congruent or the same as angle 7. And angle 4 is congruent or the same as angle 8. So if two angles are corresponding angles, they are also congruent. So you can see there are all kinds of congruent angles in these parallel lines cut by a transversal. So when we have this situation, so look at this example where we have line R parallel to line S, and it's cut by this line W. We've got 8 angles, and I only know one of them. We can actually find all 8 angles if we only know one of them. And there's a lot of ways to prove what these angle measures are. So let's go through and see if we can find all of the other 7 angles now that we know one of them. Well, I know angle 1 is 128 degrees. So I can find angle 2 because they are supplementary angles. Angle 1 and angle 2 are supplementary. They will add up to 180 degrees because they form this straight line here, line R. So I know that 128 plus angle 2 is going to be 180. So angle 2 must be 52 degrees because angle 1 plus angle 2 is 180 degrees. So now that I know angle 2, I know angle 3. What kind of angles are these? Well, they're across the vertex from each other with crossed lines. These are called vertical angles. Angle 2 and angle 3 are vertical to each other, so they're congruent. So angle 3 is 52 degrees. It is vertical to angle 2. And then angle 4, well, that's vertical to angle 1. Angle 1 and angle 4 are congruent because they're vertical to each other. So angle 4 is 128 degrees. It is vertical to angle 1. We also could have said it's supplementary with angle 3. So angle 3 and angle 4 must add up to 180 degrees. Or even angle 2 and angle 4 are supplementary. They have to add up to 180 degrees. Either way you look at it, we come up with 128 degrees. So now angle 5. How do we figure out what angle 5 is? Well, there's a lot of ways we can do this using the angle relationships I just talked about. Angle 1 and angle 5 are corresponding angles, so they have to be congruent. So angle 5 is also 128 degrees. It is corresponding to angle 1. Or it's an alternate interior angle to angle 4. Angle 4 and angle 5 are alternate interior angles. So that's another way we could prove that it's, again, 128 degrees. So lots of ways we can do this. So now you can see really there's only 2 angles in this whole diagram. And we just have to figure out, is it going to be 52 degrees or 128 degrees based on the angle relationships that we know. So angle 6, how big is angle 6 going to be? Angle 6 is going to be 52 degrees. Why? Well, there's a lot of ways we can prove it now. It's supplementary to angle 5. It corresponds with angle 2. That's the one I'm going to write down. So it's corresponding to angle 2. It's alternate interior to angle 3. And I think that about covers it. So angle 7 is going to be 52 degrees as well. And how do we know angle 7 is going to be 52 degrees? Well, again, a lot of ways we can prove that. It is vertical to angle 6. Angle 7 and angle 6 are across the vertex from each other. It's also corresponding with angle 3. They're in the same position, but on different parallel lines. It's also an alternate exterior angle to angle 2. So it's going to be 52 degrees. So all 3 ways we can prove that it is 52 degrees. And then finally, angle 8, that's going to be 128 degrees. Because the easiest way to tell that is it's vertical to angle 5. Vertical angles are pretty easy to identify. It's vertical to angle 5. It's also supplementary with angle 7. It's supplementary with angle 6. It's corresponding to angle 4. And it's an alternate exterior angle with angle 1. So lots of ways to prove a certain measure when we've got parallel lines cut by a transversal. So essentially, there are really only 2 angle measures when you've got parallel lines cut by a transversal. It's either going to be congruent to that or it's going to be supplementary to that. And that's what we're talking about today, are these special angle relationships.